In this part, I will show how I created the Linux server virtual machine in VirtualBox and configure its network adapters so it can both access the internet and communicate with the client on a private internet network. Now I will configure the server network. I select the server VM, go to setting and open the network tab. For adapter 1, I set it to NAT. This gives the server internet access to the host machine. This matches the ETH1 interface and our network topology. Then I enable adapter 2 and set it to internal network, making it INTNet. This is the private network the client connects to, and it matches the ETH2 interface that communicates with the Linux client. I make sure the client VM uses this same network. I make sure the client VM uses the same network and name so the two machines can talk to each other. I open the client, do the same on the client. One,
Assalamualaikum warahmatullahi wabarakatuh. My name is Absyadin Husni bin Azam Husni, matrix number B1525103117, and I am going to demonstrate you on how to initialize the TCP server in Debian. So first and foremost, before we start, we have to check the port setting on both of our profile. As you can see right here, I set two profile, server and client. So let's see on server. So as you can see here, in the documentation, we were supposed to set port 1 as the default, and that is the NAT. And the second adapter is to set to internal network. So this is the configuration, as you can see here. So that's it for server. So now let's get on to client. Let's see on network. So for client, we have to set one port only, and that is internal network. This is for the communication between client and server. So this allows for client and server to communicate closely in a single file network. So let's get straight to the configuration. Okay, now we're on clients. Oh, my bad. Okay, let's get on to server. So we go on ahead and open our terminal. So step 1, we have to assign a static IP into the secondary port, which is the adapter 2. Let's see the network configuration over here on Debian. Okay, so as you can see here, okay, this is port ENP0S3, which is used for NAT, for network connection, and it's supposed to have another one port, but we have to initialize and enable it by going through the terminal. So first step, we have to assign static IP to the port. So let's go on ahead and put on this command. And go on ahead and put your sudo password. Oh, okay, my bad. Okay, so this is the command that required for you to put into the configuration file. So what this does is over here, as you can see, this is the secondary port, which is assigned by Debian. So this is the actual name for the port, and that is the ENP0S8. So yeah, over here, if you can see this, ENP0S8 innet static. So what this line does is it set the secondary port, which is the internal network port, to a static condition. And also in the documentation, we are required to configure a static IP address, which is the 192.168.1 and 0.254. And the logical net mask should be 255, 255, 255, and 0. So this is the configuration required, and that's easy. So the second step is we have to install the DHCP server service by installing the required package. So let's go on ahead and type sudo. Okay, my bad. We have to apt update first. So let's go on ahead. Okay, so after this one, you should be able to put on this command to install the required package for the DHCP server. So what this line does is it installs this exec package, and what does this dash y, it auto reply to any prompt for the package to install. Maybe like do you want to install this package, yes or no? So it defaults to yes. So let's go on ahead. Okay, so as you can see, we have installed the required package because I previously installed this package, and this is actually my third try performing this demonstration. So I'm sorry, doctor. Okay, so let's go on ahead and configure the port used for the DHCP server. So let's go on and type this command: dc/default/isc DHCP-server. Okay, so by default, in this exec file, there should be a blank. There should be a blank. I mean, like this file is supposed to be blank over here on the v4 and v6. So what you need to do is to put the required port, which is the ENP0S8. So this by doing this, you actually use the actual port to be used for the DHCP server. So let's go on and exit. So the next step will be the edit the actual configuration for the DHCP server. The last one is to configure the port use, and this one is to configure the service. So let's go on ahead and put on this command. Okay. Okay. Let's go to below of this file. Let's get to the bottom of this file. Okay. In this dot text section, it is supposed to be in command. I mean comment. So it should be like this. So, with this, you're supposed to delete the. Should start over here, over here, over here, and over here. So what this actually does is to initialize the lines, because apparently all of these lines are commented so that the default configuration would not interfere with our setup. So let's get over here. By default, it is supposed to be different from what happened over here. So what you need to actually do is head over here onto subnet is to put the IP address, and that is the 192.168.1 and point 0. And for the net mask, it's the same as the initial port configuration. We do it at the first step, and that is the 255, 255, 255, and point 0. So let's get over here on range. So for this range, you have to, we are required to refer to the documentation, and we have to put this exact range. So what this line actually does is to start the IP address to provide for clients to connect by starting with 192.168.1.5 up until 192.168.1.1 and 192.168.1.10. Okay, so it ranges from 0.5 to 0.10. Okay, so this line is the DNS. By default, I am going to put it to 8.8.8.8. And for this one, this is actually optional, but you can use it to display your server name. So what this actually does is when we are in a situation of pinging server, so when a server is connected with client, client don't actually have to put the exact IP address of the server to ping it. So what this line actually does is you can actually ping by using this name, mydomain.example, and it should it should ping correctly. So on the routers, this router, this exact line is we are required to put the server's IP address, the static IP address that we put initially on the first configuration. So, and then don't forget to close this bracket, close these lines with this curly bracket. So let's go to the next step. Okay, so all of the configurations are done. So we have to restart the port and enable the DHCP service package. So what we are going to do is we have to type this command. Okay, so this command actually disables the port, and this following command is supposed to re-enable it. Now we have to restart the whole network for the configuration to actually initialize. Okay, so this is the lines required to restart all of the ports and all of the network in this Debian. So the next one is to restart the package, the service, the DHCP service, my bad. So let's go on and type restart the package, and that is named as IC-JCP-server. Okay, so if there aren't any errors appeared, you're actually good to go. So let's go on ahead and check our server's IP address. Okay, so as you can see here, it actually used our initial configuration of the port, which is the 192.168.1 and point 254. So this proves that the configuration is a success. So let's go on ahead to client. Okay, let's log in. And let's open up terminal. Okay, so on this part, we have to run this the same command to check our IP address for client. So as you can see there, client has successfully gained an IP address from DHCP server, but we have to try and gain another IP address by manually use commands. So let's go on ahead and put on this command. Okay, so what this command actually does is to remove the current IP address from our virtual machine. And let's go on ahead, type our sudo password. Okay, so the next command will be asking the DHCP server to give us a new IP address. Okay, so that's all done. Let's check our IP address. Okay, as you can see there, we have different IP address over here. 192.168.1.6. The initial IP address is 192.168.1.5, and that proves that this DHCP server is working correctly. So let's go on and test ping. So we know that our client's IP address is 192.168.1.5. So let's go on and try to ping it. And type this exact command. 2.168.1.6. Okay, so as you can see there, our communication between server and client is working correctly. So let's go on ahead and try client side. Okay, as you can see there, client is able to ping the DHCP server correctly. So this proves that the communication is working correctly. So let's go on ahead and test each of server and client internet connectivity. So by default, client is supposedly are not able to connect to any internet, any website, because this DHCP server is not configured to provide an internet access to client. So let's go on ahead by pinging a random domain name service, domain name server. So let's go on and use Google's DNS. Okay, so as you can see there, server is able to ping the DNS correctly. Let's go on ahead to client side. Okay, so we have met with a zero transmission. Okay, so as you can see here, 4 packets transmitted and 0 received, and 100% packet loss. That means our connection to the internet is not working correctly. So that is supposed to happen with client side. That proves the DHCP server is working correctly again. So to double check, let's go on and access any website. Let's go on to Mozilla. Now let's search anything. Okay, let's wait until it provides any message. Okay, so as you can see here, the browser said that we can connect to the server at www.google.com. So that is supposed to happen. As I said before, DHCP server currently isn't configured to provide any internet access. So let's go on to our server and check internet connection. Because server has 2 ports that each provide its own function. So the first one is the adapter one, which is the ENP0S3. That provides normal network connection because it uses NAT. And the second one is the port that is used for the SP server. That is supposed to be used for our connection between server and client. So let's go on ahead and search google.com. Okay, as you can see there, the website is working correctly and server is able to connect to Google correctly.
Assalamualaikum warahmatullahi wabarakatuh. Uh, so, my name is Syed Mohammed and I will present the demonstration for SRTP server. So the first command before start is sudo apt update. First we update our system package list to make sure we get the latest software version. And next we install the OpenSSH server so our machine can accept secure connection and the dashboard just automatically approve the installation. Alright, the download is finished. We check the status of the SSH we just installed using the sudo systemctl status SSH. As you can see, it is active and running, so it's all good. Then next, we need to create dedicated SFTP group and users. First, we create a specific group called SFTP users to manage our file transfer clients together. Then we add the user to our SFTP group and change their setting so they can only transfer files, blocking them from accessing the server's commands terminal. Then we set a password for the user, which is client2. Alright. Then inside their home directory, we create a specific folder called uploads where they can actually manage files. Security, we give ownership of the top level folders to the system root. This is a strict requirement to log the user in. So the command is sudo chown root root var sftp space var sftp client2. Then we adjust the permission so the folder is readable by the user but they can't change the main directory itself. Using the command sudo chmod 775. And finally, we give our user full ownership of that uploads folder so they can drag and drop files into it. Now we open the main SSH configuration file to apply our custom security rules. We need to scroll down. So we delete the line. Then we read subsystem SFTP internal SFTP. Then below we write match group SFTP users or target only the users in our SFTP group. And then chroot directory percentage is to log them into their own home directory so they can't spy on other system files. Also post command internal dash SFTP is to force them to use SFTP only, completely disabling terminal access. And last, allow TCP forwarding no and adds one forwarding no. This is to turn off advanced networking features for maximum security. Then we can save the file. And then we restart the SSH service to save and apply all of our new configurations. Then we run the command hostname -i to grab our server IP address so we know where to connect from the client side. Now we log into the client side. Now we want to create a file named test1.txt in the client side. And create another file named test2.txt. So we want to write something into the test2.txt, which is hello client 2 as FTP. And then we save. We need to adjust the version again, so from 775 to 755. Then we try to connect again, and then the connection is successful. So if we ls, as you can see, we can view the upload directory. Alright, we uploading the text to txt to upload to the directory. And then if we analyze it, they are test2.txt. So we just verified the user can only access the upload folder. As you can see, the permission is denied. Now we open the FileZilla application and we enter the IP address 192.168.1.254, and then the name client2, the password that we did set before, and we click quit. So you can see there are the directory uploads on the remote side and the file, so we can access the file from the remote side. You can see there are the inside the client2, there are the test2.txt that we upload, and there are the message which is we wrote before in the client side, which is hello client2 FTP. That's all. Thank you very much.
Assalamualaikum, my name is Edina Abdul Aziz. My message number B11525100063. In this demonstration, I'll be working through section 7.0, a web service. A web server is a software that stores and delivers web pages to users through a network. In this project, I use Nginx to host a simple web page that can be accessed from both the server and the client. I'll show how to install and configure an Nginx web server on a Debian Linux server VM, then verify the connection from a separate client VM over a virtual network. First, I switch to the server VM. I update the Docker Debian package index and then install Nginx. Please refresh the package list and install the Nginx web server automatically without prompting for confirmation. Next, I'll start the Nginx service and open the server block configuration file for my site. Inside the editor, I'll add the following server block configuration. Now I create the directory that will hold the website file, for example.com, keeping it separate from the default root. I create a simple HTML landing page and then assign proper ownership to the Nginx web server. The echo command write a basic HTML heading into index.html and give www.data full ownership of the folder. Now I will enable the site by creating a symbolic link from site available to site enable and then test the Nginx config for any syntax errors. If the configuration is correct, Nginx will report syntax is okay and test is successful. I will restart Nginx to apply the new configuration, then allow HTTP and HTTPS traffic through the UFW firewall using the Nginx full profile. Before testing, I'll check the server's active IP addresses and install the CRU for command line HTTP testing. The hostname command shows us the server's IP address. Here we can see the static IP 192.168.1.254 assigned to this server. Now for the testing phase, first on the server, I'll check the Nginx service status to confirm it is running cleanly with no errors. The output shows active. Nginx is healthy and operating correctly. Next, I'll attempt to fetch the web server headers locally to confirm Nginx is responding to HTTP requests. I'll run the curl verification command again to confirm the server is properly serving web traffic locally. We can see the response show http://1.1.200 OK, confirming Nginx is running and responding correctly. Let me verify the server's network IP address to ensure the static configuration is properly bound to the network interfaces. We can confirm the server is assigned the static IP 192.168.1254 on the private virtual network. Now I open the Firework browser on the server VM and navigate directly to the server's own IP address to verify it served the page graphically. The welcome to NGX default page loads. This confirms the server is running accessible over the network. Now I switch over to the client VM. I check the client machine network configuration to verify its IP assignment on the private virtual network. We can see the client has been assigned IPs 192.168.16 and 192.168.15 on the private network, confirming it's on the same subset as the server. Finally, I open the web browser on the client VM and navigate to the server's static IP address to verify cross-machine connectivity. The Welcome to NGX landing page loads successfully on the client browser. This confirms that the client machine can reach and communicate with the NG web server across the private virtual network.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syamil Zulkarnain, and in this project I was responsible for setting up the database service on the Linux server. For this, I use MariaDB, which is an open source database system based on MySQL. Let me walk you through how I configured and tested it. First, I'm on the server. To set this up, I start by updating and upgrading the system to make sure all the packages are current. Next, I open the limit configuration file to increase the number of files the system can open at once. This helps the database handle a large number of connections. I add these two lines for the soft and hard limits, then save and exit. After that, I open the CCTF file to tune the memory setting, lowering swampiness so the system prefers RAM and increasing the max map count for the database. I add these two lines and save it. Then I apply the changes with CCTL. Now I install the MariaDB server package. Once it is installed, I run the secure installation script to harden the database. Here, I set a root password, remove anonymous user, disable remote root loading, drop the database, drop the test database, and reload the privilege tables. I answer yes to all of this. By default, MariaDB only listen on the local machine. So I open the server, config the file, and change the bind address to 0.0.0.0, which lets it accept connections from other machines on the network. In this case, the client. I set the bind address to 0.0.0.0 and save. Then I restart MariaDB to apply the change. Now I set up the firewall for security. I install UFW, allow SSH so I don't lock myself out. Then allow database traffic on port 306, but only from the internal network, not from anywhere else. Then I enable and reload the firewall to activate the rules. Now let's test everything. First, I check the firewall status to confirm that port 3306 is allowed from the internal subnet. As you can see here, port 3306 is open only to the 192.168.1.0/24 network. Next, I check that MariaDB is actually listening on that port. This confirms the database is up and listening on port 3306. Now I switch to client. Now I will switch over to the client machine to test the connection across the network. First, I check the client's IP address. You can see client has an IP within the assigned KCP range. Now I will test whether the client can actually reach the server's database port using Netcat. The connection is succeeded, which means the client can reach the database over the network. To also confirm the DHCP is working, I will release the current IP and request a new one. Now I will check the IP again to confirm the client received a new address in the correct range. And finally, I retest the connection to the database on this new IP, sure it still works. Connection succeeded. Confirming the client can reliably reach the database service. Now I switch back to the server. And confirm it is still bound to its static IP address, which is 192.168.1.25254.
Why HTTP instead of manual assignment?
DHCP is used for automating the IP address assignments, both for present clients and also future clients.
What is the command for removing IP retrieve from DHCP?
GH client-r. Why use SFTP instead of normal FTP?
We use SFTP because it's secure and it encrypts files and passwords so hackers cannot read them. Normal FTP sends everything in plain text, which is dangerous.
I see.
What does chroot setting do?
chroot, it locks the user inside one specific folder. This stops them from looking at or accidentally changing important operating system files on the server.
Why do we need to create a symbolic link to sites enabled, and what is the purpose of running the UFW command during the configuration?
We created the symlink to activate our new site configuration file, and we use UFW to open the firewall port so external client machine can access it.
How do you verify locally on the server that means service is running and serving web traffic properly before testing it on the client web browser?
You run sudo system ctr status meets to check if the service is active and use this command. To confirm it, return a successful 200 OK status code.
What is the standard command used to start the MariaDB database service on Debian 11?
Sudo systemctl start MariaDB. Okay.
What is the name of the default command line tool used to log into and interact with a PostgreSQL database?
PSQL.